YouTube. We should be back once again as there were some technical difficulties with the functioning of software, or perhaps it was the internet. Maybe there's communication problems because there are multiple different radiation storms and things going on at the same time. So maybe it's that. I don't know. But in any case, we're going to let the stream run like all day today. So what we're showing down here in the lower left, this is the auroral oval. You can see that on nullschool.net. Here's the southern hemisphere version. And of course the auroral oval will be bigger down there since it is indeed summertime in the land Framunda. So if you have seen the aurora, let us know in the comments. And you know, if you've taken photos of it or video or something like that, hit us up somewhere on social media and we'll consider showing your aurora photos, video, etc. on the channel. It could happen. Just tag us on Twitter, or I mean, we're on Facebook as well. You should follow my personal account on Facebook. I'm also going to put the homepage in the chat. That'll have the homepage, smashomash.com, does have a link to the Discord channel. That is the easiest way to get a hold of me because you can send me an instant message. So there's all kinds of ways to contact us. Feel free to do so. Let's cover some of the weather that we didn't cover during the regular stream. So we're going to show Earth's weather here real quick while the solar data continues to play here. But we're going to switch this to the house favorite. Hey Microsoft. Hey Google. Hey Microsoft. Hey Twitter. Hey Google. Hey Microsoft. Hey Twitter. Hey Google. Hey Microsoft. Oh my gosh. Wow. Good idea, the Marion Lewis. Damn, negative 36 degrees Celsius, negative 34 degrees Fahrenheit. I'll bet we can get some comments on this. Anybody want to leave comments? Anybody want to leave comments? It's not the coldest place in the world right now. Isn't that exciting? I'm so excited about it. I can barely contain myself. Let us know if you're patronizing DraftKings. Yeah, sure. I'm sure there's lots of betting going on right now, right, folks? People aren't financially crippled or anything. No, no. The economy's doing wonderfully, isn't it? Anyway, we're going to let this stream run just because. So feel free to leave a comment, press share, see the other streams. I don't know. I don't care. I'm not providing links. Visit the homepage. Hit us up on Discord if you want to send an instant message. Maybe we'll even put you on the live stream. Like, we'll let people talk, actual viewers. Like, just let them tune into Discord and talk. That could be a thing. But at the moment, we're just going to let this stream and so enjoy. And we're going to actually, let's see, we won't worry about 195 angstroms, although it is good at showing those coronal holes. They're all of North Pole orientation, by the way. And it looks like a deer, a young fawn. See, here's the head. So yeah, let's show 94 angstroms. And we're just going to let this run along with the auroral oval. So enjoy. Be right back, YouTube crew. I am nearby. So I just got back from doing an outdoor weather check here in Lehigh Valley, PA, and it's a little on the cool side out there. Forecast high for today is going to be like, I think it's 20 degrees or something. So got a serious cold spell going here. Now, we do want to cover the stuff that we normally cover. So we are going to do that. Our earlier streams were interrupted quite rudely, I might add. So, but what we're showing here is we're showing over here on the left Earth's auroral oval, and then above me here we're showing the GOES 19 SUVI, because there still is some significant flare potential. But let's take a look at some data here. So like we said earlier, sunspot number is now way up to, what is that, 176 sunspots, 177 sunspots, something like that. We saw a big Forbush minimum. We have a proton event going on, so there is additional radiation being emitted, especially at the polar regions. There are ongoing radio blackouts. But at the moment, the background X-ray flux is only about a C1, so not a big background flux, but there still is potential for large solar flares. We have interacting, you look at these sunspots, this sunspot here and this one up here, these two sunspot groups, they have interacting plasma filaments. So that's, You can see that there's a filament right here that stretches all the way across. Let me advance that. There's today. And you can see there is interaction going on between these groups across the solar equator. So as those sunspots change and evolve, the likelihood of them becoming unstable and that plasma filament following suit is quite high. So don't be surprised to see an M or even more X-class flare events. At the moment, it doesn't look like there's any new major CME headed Earth's way. Let's take a look at the heliosphere. That's what we're showing in the lower left now. Earth is about to move into a South Pole-oriented magnetic sector. As you can see there. Right now, Earth is in a North Pole magnetic sector. But the boundary crossing is coming. So there's going to be a transition from magnetic field lines pointing toward Earth to pointing toward the sun again, as Earth will cross two current sheets out of the North Pole sector into the South Pole sector in the coming 24 hours. So by tomorrow, we should be close, if not already in the South Pole magnetic heliosphere. So that will be accompanied by South Pole-oriented coronal holes. And there you can see them rotating in on the east. This is our line of sight coronal hole plot. This is the top view ecliptic plane field plot. You can see those North Pole-oriented coronal holes shaped like a deer. It looks like a fawn. Really. Certainly not a buck with a rack. Next, we'll look at magnetograms real quick. We'll go to Cerro Tololo, Chile. So here is just today's magnetograms, and we'll zoom out enough to show the time and date stamps. There we go. That's pretty good. I like it. So there you go. Now, we don't have all that much magnetic shear. These actually don't look all that likely to produce large flares on their own. But again, there is a plasma filament stretching over 100,000 kilometers across like 1/3 of the solar disk. And we do have some more sunspots over here. So let's take a look at those in... We'll look at red light. So a new sunspot here in the southeast as well. That's pretty cool. I'll take it. But these sunspots that are in the Earth-facing zone here, these are magnetically complex. They're just not particularly active, right? So they're beta gamma class, but I don't think they're beta gamma delta class. We do see, you know, opposite polarities that are on the same latitude line. I should say, I'm sorry, the same longitude line. So if you draw a vertical line based on the sun's contour, you know, if you see opposite fields on that vertical line, that makes it a beta gamma class sunspot. And anyway, we'll also look at filaments. So here's the filament situation for today. We see a number of prominences there. There was a crown prominence this morning. Oh, that was earlier than Cerro Tololo had view of the sun because it is in Chile. If we look at, let's see, we can probably show that prominence if we look at a different Location, Udaipur should show it well. All right, maybe not. No crown prominence visible there. But it did start at about 8 o'clock this morning. You'll probably be able to see that on the GOES 19 above me here. But in any case, at the moment, we really don't need to see filaments to see a major Earth-directed CME, like more coronal mass ejections. Like, don't be surprised to see that. We do have, there is a lot of plasma suspended by these massive magnetic fields. The ones that the pointer's on here, you know, this area right here is a place to watch for days, really. Even if those sunspots degrade, there still is a high chance that plasma could become unstable and blast off. Again, follow us on Twitter if you want to name solar filaments after living people. And we see this big dip in the electron flux. Now that's an anomalous dip. That does not mean that your GPS is going to work well. So that's a function of the ionosphere puffing way up, and ultimately the altitude at which the F layer is measured is not at the same place. So the GOES satellites, they endeavor to measure this electron flux at the F layer, and if the F layer moves a lot, expands, etc., as it has during a major solar storm, then you're going to have anomalous readings on the electron flux. It's not really as low as it looks. Total electron content is going to show some forecasting for that. So as you can see, huge electron clouds are expected over the planet because, hey, it's called space weather. So this is showing us all of the electrons to, you know, all the free ions, I'll say, up to about 26,000 miles of altitude, all the way down to ground level. So that's where you would expect the biggest GPS errors, and as you can see, huge ones here expected over the Pacific and so on as the day progresses. Here are the radio blackouts that we were talking about. If we do see more flares, expect equatorial radio blackouts, but expect ongoing radio blackouts for the polar regions. As you can see here, the D region is, it's like a sieve. Those signals are not bouncing off of it as they normally would. So this is the time when astronauts and polar flights experience a lot more radiation. So flight crews that are flying in those areas where you see that huge attenuation of the D region shown in that imagery there, it looks like the North Pole portion of it is starting to subside a little bit. So keep in mind that's the proton event, folks. That is not the CME impact. That is the SEP impact. That goes on for days because those particles continue orbiting the field lines at extremely high voltages. We're talking 10 to 50 million volts for those protons. Here's just a diagram of the layers, just so everybody knows where things are. I know geography is super important, so you want to know where things are when you're thinking about them, because that's how we conceptualize things. And we'll skip the ionosphere maps for today because it's really not that crucial. The script should be referenced with a method of post. I don't know what the hell that means, but okay. Thanks for the info. Now, are you out there believing that Earth is shaped like an oblate spheroid? Now, what kind of nonsense is that? Check the description. You can find our Redbubble shop. When will you stop believing NASA's lies and understand that Earth is croissant-shaped? I mean, what? Like, look. There it is. Stop believing these photoshopped images that NASA puts up on the internet, trying to convince people Earth is shaped like a sphere. It's evil and satanic, folks. Earth is shaped like the French breakfast pastry, the croissant, not like a sphere or a snow globe or a pizza. It's not shaped like a pizza or any of that stuff. It's shaped like a croissant. Are you getting hungry? This script should be referenced with a method post. What the hell does that mean? Just load the page. It's got a URL, dude. What are you talking about? A method post. Your soul is a method post, Chromium. That's Chromium browser that's giving us that message. I don't know what the hell that means, so I don't understand it. It's thanks. Forbidden. Ah, that's fun. URLs are fun, folks. Good Gond. Dear Gond. Oh, I see. Because that's like the... My bookmarks were broken when I imported them. Oh, noes. So this is what we usually show at this point. The visible satellite imagery of the closest planet, the one you're probably on if you're not an astronaut. Let's show 40 frames today since we're coming at you kind of late. Nearly 9 o'clock. So there's that blue globe, the one inundated with software that's barely functional. You know, you've been there. You've been there. If you are viewing the video from a different plane of existence, timeline, multiverse, universe, planet, spacecraft, star, satellite, etc., civilization, simulation. Oh, because that's not a thing, but wherever you're viewing from, leave us a comment. Tell your friends and foes, and don't forget to press the share button. And we are in the chat, by the way. I do see the chat there, sort of. All right, so let's continue on here with the daily space weather video. You may find this in you may find previous versions of this content in the live streams section on our YouTube channel, youtube.com/smashomash/live. And yeah, that's what's going on the Atlantic Ocean. Let me grab that URL. Can I get a URL, folks? Yes. The answer is yes. All right, let's show the U.S. water vapor map as we're wont to do. We do have some incoming weather. We're going to show forecasts like we usually do on the morning streams, because we've got some major stuff coming. We've got some serious snow possible for Lehigh Valley, Pennsylvania. So some big forecasts in the 6-day. But as you may know, if you're a regular viewer of the channel, a 6-day forecast is too damn many days. That's how you get forecasts that are not accurate or relevant to anything in reality. So we're going to show some 3-day forecasts. Make sure you tune into the channel in the next couple of days, because we could get a foot of additional snow in Lehigh Valley. So now I like getting snowed in, especially if I have sufficient provisions, which we're working on. But all that aside, welcome to space. Here's what's going on with the water over the U.S. See that? That's the water vapor over the U.S. And major dry air there over Arizona and New Mexico. while moist air drives down through Montana, pushed by cold, drier air, once again compliments of Canada. So all you Montanans out there, you can thank your Canadian pals for supplying that frigid air. And I don't mean the fridge, not the brand. Here's your Lehigh Valley forecast. It's currently listed as 11 degrees Fahrenheit at the ABE airport. That's where the Allentown forecast comes from, the ABE airport, folks. So depending on what you're looking at, if you look at data about the temperature where I'm at, you might think it's 11. It could be 12 or even 9. But yeah. And the wind chill is -2 Fahrenheit, as if 11 Fahrenheit's not cold enough. Anyway, here's a U.S. Doppler radar. Some lake effect snow continues on the east banks of the greatest lakes in the world, the most amazing, most beautiful, most spectacularly ginormous lakes in the world. Okay, I mean, those are some lakes. The Russians, Putin, they might tell you Lake Baikal is some kind of a better lake, but we're looking at renaming Lake Michigan. We're gonna rename Lake Michigan. It's gonna be known as Lake Trump, okay? Lake Trump. It's gonna be the most amazing, the most beautiful lake. And we've already got the permit process in effect to put a giant gold T right in the middle of Lake Trump off the coast of Milwaukee. It'll be high enough that you'll be able to see it from Milwaukee, though. So it's gonna be amazing. It's gonna be just amazing. China doesn't have any kind of golden T's in lakes like that at all. China can't do it, and they can't keep up with the AI revolution either. Okay. So there's that moisture heading into the U.S. You can see snow falling in, thanks to the Canadian cold air smashing into a bunch. Well, you get the idea. I showed you the thing. So it's also incredibly cold. Here's our windy.com temperature map. And dude, look at the cold. Madison, Wisconsin, -6 degrees Fahrenheit, dude. That's not wind chill. That's the freaking temperature. That is a thermometer measurement, okay? -6 Fahrenheit. You can throw boiling water out the back door. But don't throw boiling water up your back door. That would be really unfortunate. But you could throw it out the back door, and there's a huge suction happening here, because you see the Great Lakes, all bodies of water, they accelerate winds because the winds want to blow a certain direction based on where the high and the low pressure is located. The winds want to blow a certain way. And when you have major pressure gradients, the winds get very strong, like with a hurricane. And when the winds get very strong, and then they blow across water, they only have one way to blow. So the air is pulling on the other air. There's surface tension. It's pushing and pulling the other air the whole time. So, for example, if you look at where the pressure is located, right? Let's bring up the pressure map here. You see how the pressure is much lower on the Great Lakes? So all this air is being pulled toward that, as you can clearly see here. So there's the windy.com animation, and you can see that all this air is being pulled straight toward Sault Ste. Marie. And that's how weather actually works. Anyway, here's a satellite image. And look, it's not necessarily going to be obvious why this stuff happens, but like, this is how weather works. So it isn't man-made. Man doesn't have the capacity to control the weather, folks. They can make tiny, tiny little tweaks. If you zoom all the way into a single mountain, they can make it snow here instead of here. But that's about it. So if you are chemtarded, if you if you are chemtarded in that you think that there's some kind of magical spraying program happening, leave us a comment. But keep in mind, since we are free speech absolutists, you will be lambasted in the comments, or lambasted if you prefer to pronounce the word correctly. But yeah, there are those clouds building up there as the air slows down on the wayward side of those Great Lakes. That's literally the air piling up on itself, because air is a fluid, folks. So, when you get into large scales, things don't work the same as they do in your bathroom. But in any case, yeah, there's our satellite map. We'll zoom out and show you the full view here. There's a fantastic satellite view. We're going to switch to visible light. There you go. It'll show the day-night Terminator. And you folks out on the West Coast, it's not quite dawn yet, so maybe get out and look to the north, as we could have some major events going on, right? We talked about it earlier on our earlier stream. Check out the solar wind conditions, y'all. Oh, a big dip in the solar wind density. But we still have a very high solar wind velocity there. So you can see it's 820 kilometers a second yet. Still quite fast. But check it out. Now it looks like a coronal hole high-speed stream, because it's only 0.33 protons per cubic centimeter. So look out, folks. It must be the Illuminati controlling the solar wind, because it's 0.33, right? The number 33 is totally not arbitrary based on the fact that we have 10 fingers or anything. No, the number 33 is very important because reasons. All right, so yeah, we do have a slight negative BZ here, so expect geomagnetic storm conditions to continue. Let me set this up the way I want it. I like the black background. I like the... What do I have usually? I think I put the prediction, no, I put the KP plus AP, right? There we go. Now it shows the KP index, and there you can see KP8. So the next time we see an update on this, oh yeah, we're going to see a dip. So it's KP is going to go down to like 6. Because, look at that, the latest update here, we have a big dip in the solar wind density. So this is going to almost provide a formula to help people understand sort of how the different parameters work into the actual KP index. Now keep in mind, this is all sort of mitigated by the BZ, which is that top line there, and the upper line there, the white and red lines. The white line represents the BT, that's the total field. And this is measured at Lagrangian 0.1. All right, so this is where those spacecraft orbit. They orbit this Lagrangian point, and it's very large. There's actually a visualizer for that, which we will show you in a future stream. But L1 is where the ACE and Discover spacecraft are located. They orbit that gravitational equilibrium point. And so the current conditions are total field of 15 nanotesla with a BZ of -8. That's conducive to inducing current into the Earth system. But the field has dipped a lot. So it was up to 90 nanotesla earlier this morning. Now it's down to 15. So also the solar wind density has dipped a lot, as you can see there. Now we're only at 0.3 of a proton per cubic centimeter. So less than 1 proton in a cubic centimeter. That's very diffuse. But the particles that are there are moving at nearly 900 kilometers per second. So anyway, that's what's going on with the solar wind. This major geomagnetic storm is about to subside a bit because of that dip in the solar wind density. Now, there could be multiple clouds that are like, what's the right word? That are nested within each other, like Russian nesting dolls. But the harshest part of the geomagnetic storm may already be behind us. Now, we didn't cover this earlier, but this is where planets are located. And of course, when we look at the coronagraph earlier, we did see Mars and Venus and Mercury in there. Pardon the ad. It's theplanetstoday.com I like to use. And we do not endorse whatever the hell that was. Proton storm continues. There's the ghost proton flux. Although it is subsiding, so you can expect the radio blackouts to end in the northern hemisphere first. Still a couple days ahead with radio blackouts in the southern hemisphere around the poles. A little bit of flaring here happening in the past couple of hours. Namely, peak flux was, let me set this to a 1 day. Peak flux was about a C 3.9. That's not very big. And just after 1300 Universal Time, let's get a beat on that flare. I suspect it's from this southern Earth-facing group, but let's take a look. Interesting. I'm not sure if that's a limb flare or the one on the Earth-facing portion. Let us know in the comments what you think. I think that's the limb flare. So that's this flare over here, I think. So that's interesting in that new active region has now produced the largest flare of the past 24 hours. So that's noteworthy. Although yesterday evening we did have an M9. Oh, maybe not an M9. An M7, an M8. There was an M8 last night at about 1900. Let's take a look at that one. That'll be the most important flare. I'm sorry, that's the largest flare of the past 24. Okay, what the heck? Where is that? I see no such flare. What's up with that? On the 19th, there was, I'm sorry, not an M9, that's a C8. A C8. But still, where is it? At 1922. Really? Is it on the limb? Tell me where. I don't see that flare. So maybe that's some kind of an overall output increase or something? Very strange. So I don't see that on the GOES 19, but anyway, there's the reading. I don't know what to tell you. It's whatever. That's the largest flare of the past 24. but we recently had a C4. C3.91. That's close. Anyway, those are the regions to watch. This region here, and this region over right there. They have interacting plasma filaments. All right, we're going to show some weather forecasts for planet Earth. Thanks to tropicaltidbits.com. All right, so we're going to show the positive snow depth change GFS forecast. And we're showing 72 hours at a time on this channel. It is what we do. It's the standard thing. So 72-hour forecast on the GFS model. There you have it. And so at least within 3 days, no new snow headed to the eastern Pennsylvania. Really none to the mid-Atlantic states at all. Central PA will see a bit. And it looks a lot like lake effect snow. That is all Canadian cold air once again, blessing the warmer moisture to its south with precipitation. Yeah. And so, yeah, we're back to Earth's auroral oval. Here's the southern hemisphere. And it does look like it shrunk, as it should have, based on the declining solar wind parameters. So that's what you would want to see if you would expect it to be accurate, and it certainly looks like it is. So that's always nice. Alaskans, you've got plenty more time to see the aurora here before dawn, so make sure you check it out. Almost the entire state there. Juneau should have aurora straight overhead, and so on. So yeah, it's exciting times for space weather. And let's cut back to the 304 angstroms wavelength, because I want to look at this morning's flare to see if there are any additional CMEs that we can see before they show up on the coronagraph. And the reason I say that is because sometimes the coronagraphs, they don't update for hours, and because of that, sometimes we can actually forecast a CME's likelihood of being earthly directed before it's on the coronagraph. That's called having skill and and knowing how to interpret the data. So look, there is a bit of activity over here. And of course we do have this crown prominence. But let's take a look at these most recent flare events. All right, so nothing major there. I don't see any major plasma releases. Besides this crown prominence is still kind of acting up. So that's southern polar crown prominence region that you see above my head here. That is a solar maximum type feature. We only see crown prominences when the sun's quite active. Otherwise, you don't see so many prominences around the polar regions. But yeah, I'm going to step away here for a minute once again. I will be back momentarily once again. If you're new to the channel, don't forget to press subscribe, like, press the share button, visit us on social media, and of course, visit the homepage, which is pinned to this chat, smashomash.com. Once again, BRB. See you in a bit. All right. Did I miss anything? I didn't miss anything, right? Cheers. So yeah, the best place, just so you know, folks, the best place to share stuff about space weather is on Twitter. All right. There is a pretty decent Twitter sphere about space weather, and it's not bad. You know, you can tweet at Tamitha Skov and Sarah Husial and Bob Lehman, and Scott McIntosh is quite active on Twitter. So lots going on over there. And so if you've got auroral imagery or if you've got questions about space weather, visit us over there. You can find all the links in the pinned comment at the top of this chat. You know, just tag us at SmashOmash, press follow so that you see the tweets. I don't just rage about AI all day long, but you know, with the current state of affairs, not too pleased with the AI. So there is some trepidation when it comes to adopting certain things that don't work. Some of us, like gamers, because I'm a gamer, some of us are not appreciative of defunct software and hardware. And we don't appreciate our hardware becoming obsolete before it's obsolete. That's extremely, what's the right word? Frustrating. It makes some people wish that certain servers and certain corporate desks become the bridge between meteor and meteorite. Anyway, yeah, so we're just going to let the stream run for who knows how long. I mean, but it seems to be stable now, which is amazing, because earlier the streams got cut off repeatedly. So now we'll just let it run, and that way it's like an ongoing chat room. But the best ongoing chat room is the Discord chat. So there's a permanent so you need an invite link to be on a Discord chat, and that link is right on our homepage, so it's pretty easy to find. And yeah, so that's like the ultimate way. And you know, when we have guests on the channel, that's what we use. We use the Discord channel. So you're like one step away from being directly involved with the channel. But in any case, I just figured I'd bring that up. Let's take a look at Earth's waves, because I want to know what the biggest waves are. So this is currents, like ocean currents. If we switch to waves, we'll see the world's largest. So the North Atlantic continues to have some nasty 35-footers up there. So that is not a place for Leif Erikson to be visiting Newfoundland in an open-top rowboat. Those are 35-foot waves. 35-foot waves, folks. So yeah, there's some surf there at Newfoundland. Let us know if you're surfing Newfoundland. It's one of those delightful places where you need a dry suit to surf. That's fun, right? Who doesn't want to don a dry suit to ride some waves? I'll tell you who doesn't. The inhabitants of the Aleutian Islands. This is the best surf in the world. Look at this. 30-foot waves at the shore. 30-foot waves crashing on the beach. That is bonkers. I mean, look at that. There, read them and weep, folks. 29.9-foot waves. That is probably not a particularly inhabited place. What do you say? 4 people live on that island. Did you know that Earth's entire population could fit on the big island of Hawaii? A lot of people think Earth is overpopulated. See this white outline? That's the outline of the big island of Hawaii, the one that has the big volcanoes, like Mauna Loa. And not only could you fit all of the Earth's humans on that island, of course they'd be standing side by side, it would be crowded, but nonetheless, to everybody out there who thinks Earth is overpopulated, let's review how populated the Earth is. So there it is. Oh, look how big it is. The big Isle of Hawaii. It's huge. Oh, it's so huge. And there is a lot of surface area because there are huge mountains on there. But the point is, if you stood people side by side on that mountain, because the whole island is a volcanic mountain, which continues, it's a sea mountain. It continues under the surface. It's a very deep ocean there. If you put the whole world's population on the big Isle of Hawaii, there'd still be room for like 2 billion more people. So, not only could Earth's entire population fit on the big island of Hawaii, there'd be room for billions more. Now, let's review how much space that really is. Imagine if you evacuated everybody from everywhere and dropped them all off on Hawaii somehow, right? Now, yes, it would become a humanitarian disaster rapidly, but just for sake of argument, let's say they're in suspended animation so they don't pee and poo on each other, right? You still got room for 2 billion more people just on that island. Now, I've driven across the US. I understand how space and population relate, all right? Tokyo is very population dense. Iowa and Wyoming are not very population dense. So let me zoom out, since, does anybody object that all of Earth's population could fit onto, wait, it's this way, could fit onto the big island of Hawaii? By the way, the Iron Man takes place like right over here. Right over here, there's like Hilo Bay. That's where the Iron Man happens. But I digress. So let me zoom out, just in case you think the planet's overpopulated. Just in case you think mankind is in control of the planet somehow. If you think everybody could jump up and down and the whole planet would move, because it does, but to a very tiny extent. And the crust is flexible and it's very complicated. But let me zoom out. Let's just assume that all of Earth's population fits on the big island of Hawaii. And we'll zoom out. All right, so now it's tiny on the map. And let's come over here and look at, oh, I don't know. What's a heavily populated zone? New York? So you think the planet's overpopulated? Really? Really? All humans could fit in that space. That one island. And people think the planet is overpopulated. It's mind-boggling. How has education failed so many people so badly? Like, you can't hear a sensational claim and have any discernment about it? Southern Ocean is also very turbulent, as there are additional massive waves of 32.5 feet. Man, look at that island. That looks like a nice place to go on vacation, right? Jeez, is that the Falklands or something? No, it's not the Falklands. They're over here. So, dude, I want to know. What is it? What is it? Somebody tell me. Never mind. Who else thinks that Google should voluntarily split into all of its constituent companies, making them all coherent and competent simultaneously? What do you think? Let us know in the comments if you think Google should split into all the different companies, where Gmail's a company, and Maps is a company, and Drive is a company, and YouTube's a company. I mean, they kind of already are, but having them all under Alphabet like they are isn't helpful. So I don't understand why they can't figure this out. They don't understand how giant bureaucracies work, because they're so smart. They're such wizards of AI or something that they don't understand how anything works. They're such wizards, they don't know how anything works. It's brilliant. Well done, dudes. Did you hear about the new VP of AI for Meta? He's a 29-year-old billionaire who replaced a guy who's an actual AI developer. But this kid who's 29, he's not an AI guy. He's just another noob making promises that can't be kept. All right, anyway, I'm going to look at this island because I want to know what it is. It's the French Southern and Antarctic lands. Oh, geez. That looks delightful. The whole thing is just a series of mountainous, rocky hills. And of course, Mount Ross. Who wouldn't want to visit Mount Ross? Me, that looks crappy. Like, it's in the middle of... Imagine how much you'd have to travel to get to this place. This would be like, geez. It's got some picturesque beauty. I'll give it that. Dag. Mount Ross. A place you'll probably never even want to go. That ain't bad, though. Do you want to climb it? If so, you're berserk. Anyway, that's what that island is. That's the French, otherwise known as the Kerguelen Islands. The Kerguelen Islands, otherwise known as the French Southern and Antarctic Lands. What a great name. It just rolls right off the tongue. The French Southern and Antarctic Lands. Brilliant. People coming up with names for stuff is just diabolical. For instance, Madagascar. Did you know that it's named after an Alice in Wonderland character, the Mad Hatter, which translates to Madagascar in the native language? Yeah. That place has got it's got mercury poisoning. The whole island, it's got mercury poisoning, folks. All right, I'm just kidding. I made the whole thing up about Madagascar's naming conventions. Anyway, some big waves there by the French Southern and Antarctic lands. What a delightful place. Let us know if you vacationed at the French Antarctic and Southern lands. Looks like a great place to surf, too. There's an offshore wind. And just offshore, 31-foot Southern Ocean waves. Another great place to put on a dry suit, even though it's the summertime. The Southern Ocean, does it ever get warm? I don't think it really does it? Anyway, let's make fun of Antarctica. Look at Antarctica. What a bitch. It's just like hanging out there at the southern part of the planet. Like, look at me, I'm the highest and driest continent on the whole planet. I have circumpolar currents. Ooh, I'm so special. I'm the biggest desert, an entire desert continent, where I only get 7 centimeters of rain per year, 'cause I'm prissy Antarctica. Look at Antarctica. It's so smug. It's like these currents revolve around me, bitch. Why is Antarctica so smug? It's like, yeah, some penguins live on my coasts. Imagine the Drake Passage. The Drake Passage is a crazy place, right? Think of the place where the Atlantic and Pacific Oceans have to reach pressure equilibrium. You know what I mean? Like, imagine if you have a hurricane on one side and an anticyclone on the other side. That'd be some shit. We actually do have a strong low here on the Pacific side of the Southern Ocean there, but you know, it's you see that there's the low. There's a surface low right there, and it's quite strong actually. I mean, the pressure is 967 hectopascals. Man, look at that Southern Ocean. It's full of lows. A big anticyclone here in the South Pacific. It is south of the equator, and you can see it is indeed rotating counterclockwise, as a high-pressure zone does in the southern hemisphere. Pressure there is very high. It's going to be 1,031 hectopascals. You got questions about how weather works? Hit us up in the comments, as it's a great day to continue monitoring the auroral oval. We'll just let it hang out. Press the now button and there you go. Press the share button if you are new to the channel, or especially subscribe. Otherwise, you might not see the videos. All right. Anyway, I gotta step away from Starship SNN once again, but I'll be back and I'll be on the chats. All right, folks, just wanted to end the stream here on a coherent note because it got interrupted again for the unknown numbereth time. So, yeah, time to close out, and we'll see you soon here at the Smash News Network, Least Busted Name and News. Don't forget to visit the links in the description, press like, share, etc., and tag us on social media if you're there, if it's coherent. And again, we'll see you soon. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. Until next time, may that solar wind be at your back.